Alright, hello everyone. My name is Gantt Meredith, and today I'm going to be covering the Exam 2 topic of dislocations. So let's go ahead and get started. Now, in a general sense, what is a dislocation? Well, a dislocation is a disturbance from the usual state, according to Merriam-Webster's dictionary. Now, if you think about dislocation and what you maybe have heard in your everyday lives, you can think about dislocating bones, right? Because you pop it out of place and it's in a disturbance from its usual state. Well, as we will soon come to find out, materials can also have dislocations, and we're going to observe two specific types of dislocations which are most likely going to appear on the exam material for exam 2. So the first type the first type of dislocation is known as an edge dislocation. So if you look over here on the left-hand side, you will see that we have a structure, and the structure contains a screw dislocation, which we'll get to next, an edge location, and something known as the Burger's vector. We will get to what the Burger's vector means in a second. I actually have a handheld model to better explain what a Burger's vector is, but for now just know that it has to do with an edge dislocation. And an edge dislocation is defined as the dislocation, or the dislocation is called a line defect because the locus of defective points produced in the lattice by dislocation lie along a single line. And that's according to the National Science Foundation. So if we look at our edge dislocation, you'll see that everything is fine in the system until we get here. There is a line defect, and it falls along this line, and you'll see that there's a disturbance right here inside our structure. That's known as an edge dislocation. And let's now compare this to a screw dislocation. So up here we see the screw dislocation on the right hand side, and it looks kind of funky. We have part of the structure coming out, part of it going in. What exactly is going on here? If you look at them and you are good at visual imagery, you could see that this bottom portion down here, if we were to squeeze that back into the material, it would actually fill the gap that's present up here. So in a way, a screw dislocation can be undone or reverted once we have created one. But how do we create a screw dislocation? Well, we make a screw dislocation by making a cut along one plane, then taking half of the plane and moving it across the other half along the path of a vector. So as you can see here, this was cut and then moved. Half of it was moved one direction and the other half stayed stagnant, or you could say that it moved in the other direction, and they are now complementary to each other. So if you were to squeeze, theoretically, the screw dislocation, it would actually go back to its original state. Here's a visual comparison, and we can see how the Burger's vector is present in the edge dislocation as well as the screw dislocation right here. Burger's vectors are more common in the edge dislocation, so we'll focus on that for today's lesson because that's most likely what's going to show up on the exam. According to Dutch physicist Jan Burgers, the Burger's vector represents the magnitude and direction of the lattice distortion resulting from a dislocation in a crystal lattice. So again, the Burger's vector does have to do with the not the edge dislocation, but with the screw dislocation as well. But we'll focus on the edge dislocation because that's the easiest for us to visualize. Now, I have my handheld model here, and if we look at it, we have pink pipe cleaners running along the side of the image. This is a 2D representation of what an edge dislocation would look like. Now, each blue pipe cleaner is the normal line along the lattice, but then if you look in the middle, we have a blue pipe cleaner that is shorter than all the other pipe cleaners. What this is telling us is that there's an edge dislocation here, and the Burger's vector can help us visualize where this dislocation occurs. That sums up most of what we're going to see on the exam when it comes to dislocations. I I hope that this was informative, and I'll be posting a picture of the physical model that I made in the comment section of this video, so that you all can look at the image as I talk about it. Thank you.